Good morning, dear students. Welcome back to physics class. Today, I would like to present very important topic, which is Archimedes principle. Today, discussing topic is Archimedes principle. Who was Archimedes? Archimedes was a very famous Greek mathematician and mechanical engineer, a pioneer in both fields, many centuries ahead of his contemporaries. Today, he is best known for formulating Archimedes' principle, also known as the law of buoyancy. But he observed many other laws of physics and regarded his observations as mathematical theorems. Before going to study the Archimedes principle, let me do one activity. Take a piece of stone and tie it to one end of a rubber string or a string balance. Suspend the stone by holding the balance or the string as shown in figure. Note the elongation of the string or the reading on the string balance due to the weight of the stone. Now, slowly dip the stone in the water in a container as shown in figure. Observe what happens to elongation of the string or the reading on the balance. You know that the elongation produced in the string or the string balance is due to the weight of the stone, which can be known by the reading of the string balance. What is a string balance? A string balance is a physical device that measures weight of an object by the elongation of its string when the object is attached to its hook. You will find that the elongation of the string or the reading of the balance decreases as the stone is gradually lowered in the water. However, no further change is observed once the stone gets fully immersed in the water. What can you conclude from the decrease in the extension of the string or the reading of the string balance? The decrease in the extensions of the string or the reading of the string balance is due to the force acts on the stone in upward direction. As a result, the net force acted on the string decreases and hence the elongation also decreases. Can you say what is this upward force acted on the stone? This upward force is nothing. It is the force of buoyancy or buoyant force. These following questions can be answered by the knowledge of Archimedes principle. First question is, what is the magnitude of the buoyant force experienced by a body immersed in a fluid? Second one, is it the same in all fluids for a given body? And third one is, do all bodies in a given fluid experience the same buoyant force? On next, you are going to study the famous statement made by Archimedes. What is the Archimedes principle? Archimedes principle states that any object fully or partially immersed in a fluid will experience an upward force which is equal to the weight of the displaced fluid. You know, this upward force experienced by the body immersed in the fluid, which is called the upthrust, equal to the weight of the displaced fluid. Archimedes' principle is also known as the law of buoyancy. You have to read the Archimedes statement once again. Let us answer this following question with the help of Archimedes' principle. First question is, no further change is observed once the stone gets fully immersed in the water in that activity. Why? Answer is, the stone does not experience any further upthrust once it gets fully immersed in the water, because weight of displaced water by the stone is equal to the upthrust experienced by the stone, which cannot be increased further. Second question is the buoyant force same in all fluids for a given body? Answer is no. The buoyant force acted on a body in a fluid depends upon the density of the fluid and the volume of the liquid displaced by the immersed part of given body. Here, this volume is equal to the volume of immersed part of the body. So, clearly it will experience different buoyant forces as different fluids have different densities. Third question is, what is the magnitude of the buoyant force experienced by a body immersed in a fluid? Answer is, it is the weight of the displaced fluid by the body. And fourth question is, do all bodies in a given fluid experience the same buoyant force? Answer is, the buoyant force acted on a body in a fluid depends upon the density of the fluid and the volume of the fluid displaced by the immersed body. So clearly, they will experience different buoyant forces as the different bodies displace different volumes of the fluid. It is an interesting story behind the discovery of Archimedes' principle. The king Hieron was a ruler of Syracuse in ancient Greece. One day, he became suspicious that his crown was made of low grade rather than pure gold. Archimedes was charged with proving that the new crown made for his king was not pure gold, as the goldsmith had claimed. But the king had not allowed Archimedes to scratch the crown and state its purity. Archimedes thought long and hard but could not find a method for proving that the crown was not solid gold. Soon after, he filled a bathtub and noticed that water spilled off the edge as he got in. He noticed the two things. First, the water overflowed in accordance with the depth of his immersion. And second, his body appeared to weigh less the deeper it was submerged. He realized that the weight of the water displaced by his body was equal to the loss of weight of his body in water. Knowing that gold was heavier than other metals, the crown maker could have substituted in it. Archimedes had his method to determine that the crown was not pure gold. Forgetting that he was untrusted, he went running naked down the streets from his home to the king, shouting Eureka. In Greek language, Eureka means discovery. He was given much appreciation and reward from the king by his discovery. This is the story behind the Archimedes principle. What was his experimental method? During his experiment, he discovered that a given weight of silver, when immersed, displaced more water than an equal weight of gold. The reason for this is that silver has more volume per weight in comparison to gold. That means silver has less density than gold. He then proceeded his experiment by submerging the crown in water and compare the water displaced by it with the quantity of water displaced by gold whose weight is equal to that of the crown. Archimedes concluded that the crown was not made entirely of pure gold, confirming the king's suspicions, and so he was able to tell exactly how much gold was missing. This method helped Archimedes to prove the king's crown was not pure gold. On your next class, you will study the verification of Archimedes' principle and its application in daily life. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.